Hi everyone, Dr. Pitcher here, and in this video I'm going to go over how to keep a good lab notebook for organic chemistry. So first thing is, put your name on your lab notebook. If you forget your lab notebook in lab, if your name is on it, then I'll be able to return it to you. Otherwise, it will go into a pile of lost lab notebooks, never to be seen again. Alright, so you've got your name on the lab notebook. And these particular lab notebooks that we're providing this year for 2024, there's actually an inside cover page where you can put subject, your name, your signature. This is the WP that I use to sign off on your notebooks, as well as email and other stuff I happen to have written here. This is a sample lab notebook, and don't confuse it with a real lab notebook. But anyway, mostly I was actually trying to test this and see how these particular notebooks, because they're new to us, how they hold up to the ink bleeding through. Alright, so let's actually turn to the next page, which will be table of contents. And you can see here that we have a little bit of some bleed through with the ink. It sort of depends on what kind of pen you have. But again, you've got your name on the front cover, name on the inside cover, and then you'll have the table of contents. Now, if you were using your own bound notebook, like let's say, a composition book, you'd want to devote a couple of pages to a table of contents. So you'd go ahead and include a date that you did the lab on and whatever the title of it is. And then there are pages here. In this particular notebook, there's one entry for every page. Okay, so I'm going to actually start here on page 2. Okay, and that's something important is I'm recommending writing only on the right-handed pages. So let's do some notes here. Let's do notes for lab notebooks. I'll take pictures or scan in what I'm writing here, and you guys can see it later, of course. So we have some notes for lab notebooks. And first of these is write on right hand page. So I'll say here in this lab notebook it's the even numbered pages only. In the left hand page, so we'll say right hand pages. Left hand pages used for calculations or to attach spectra, etc. So let's say you take an IR spectrum and you want to paste it into or tape it into your notebook, you can go ahead and do that. So write in pen except calculations can be in pencil. And notice how I wrote that in pencil there. There we go, with my trusty mechanical pencil. Okay, now these are the basics. Another thing to note is cross out if you make a mistake. And I'll show an example of that when I actually go through different sections of the lab notebook. Okay, and then we'll have sections to include in each experiment entry. Okay, and I'm kind of running out of space here, so I'm going to try to tweak the camera a little here. There we go, that's a little better. Let me just auto-focus that again. There we go. Okay, you will of course want a title. You'll want an abstract. And I'm going to go over each of these separately. I'll create a sort of fictitious lab notebook entry. You'll need procedure. You'll need data. You'll need calculations. And then you'll need some kind of conclusions. Conclusions / results. Oops. Cross it out. There we go. Results / excuse me, discussion. Okay. Now, what do each of these consist of? Well, let's go ahead and I'm going to go to my first entry here. And so there's a convenient space there for the title. And so this, I'm going to title this here sample experiment entry. And a lot of these you can leave blank, like book, project, etc. That's if, let's say you were a grad student and you had like 5 lab notebooks over the years, or 10 or whatever, you'd be numbering them. Project, sometimes you're might be working on a specific project, but you have different parts of it. You guys don't have to worry about that, so we'll just cross those out here. Date, we'll go ahead and put today's date, which is, for me, 9/2/24. And there we go. And now what we'll want to do is start out with, and you can actually, the way that you're going to write your abstract is a little bit different than what I'm going to have you do in your lab reports. So just be aware of that. So I'm going to start with abstract. What you're going to do and how you're going to do it. Okay, so that is going to be the abstract. So let's just say, as an example, I have, I'm doing a titration. So here's my example. And I'll write here, in this experiment, I will measure the amount of actually, let's change this here. So I'm going to cross that out here. I will perform, let's say I'm doing an extraction of a dilute benzoic acid solution using, I'll just say using ether. You're actually going to, later on you'll do this type of lab, but you'll be using methylene chloride. So in this experiment, I will perform an extraction of a dilute benzoic acid solution using ether. The amount of benzoic acid will be determined by titration. And a KD, dissociation constant, or distribution coefficient, will be determined. Okay, so I am saying here what I'm going to do. I will perform an extraction of a dilute benzoic acid solution using ether. And then how I'm going to do it? Well, I'm going to use ether to do the extraction, but then also how am I going to analyze the results? So what you're going to do and how you're going to do it and how you'll analyze the results. Okay, so I've indicated here that that I'm going to determine the amount of benzoic acid by titration, and then I'll also be calculating a KD. All right, so I'll give you guys some tips for individual experiments, like what to have in your abstract. All right, what's next? Well, I'm looking here, we've got procedure. So let's go ahead and do a procedure. So the procedure is what you actually did in lab. Okay? And there's kind of two methods that you can use for this. So we have method 1, write down everything as you go. And then method 2 would be write out steps of procedure beforehand. Check off as you go, writing down changes and actual values. So I'll say here, make 2 columns. Okay. Now these are the two different ways of entering things into a lab notebook, and I've actually done both of them. So let's look at what our example here. Whoops. I was going to write example in blue. I'm trying to keep things separate for you guys here. Okay, so method 1, you would say something like, I don't know, let's say 0.102 grams of benzoic acid was dissolved in, let's do 250.00 mLs of water. Okay, now I actually don't know if you can dissolve that much of benzoic acid in that much water. I'm just making this up. So that's method 1. Method 2 looks like this. You'll make 2 columns. So you'll have a column for procedure and then you'll have a column, we'll just call it in lab. So we will say here, dissolve, maybe it'd be something like weigh out approximately 0.10 grams of benzoic acid, and then dissolve in 250 ml. Let's change that to dissolve in water in 250 ml volumetric flask. And then you go ahead and list out your procedure ahead of time, and then when you get into lab, you can look at it and say, okay, I'm going to weigh out my benzoic acid here. What's my value? What's my mass? Oh, I could say 0.102 grams weighed out. Okay, so I've indicated that I've done this, but my actual value is 0.102 grams, because it's important to write down your actual value. So don't spend time, unless the procedure says to do exactly 0.100 grams. Don't spend time trying to get 0.100. If you have 0.102, that's fine. If you had 0.997, that's fine, as long as you write down, or 0.099, let's say. Sorry about that. As long as you write down what you actually use. Okay, the important thing is a lab notebook is a record of what you actually did in lab. Okay, I don't care how messy it is, as long as I don't burn myself on acid that you spilled on your lab notebook. And I have had some students ruin their lab notebooks by spilling concentrated acid on them, so don't do that. Anyway, and then we've got to check here for, yes, I dissolved it, dissolved my stuff in the water in a volumetric flask. So I might actually, in a volumetric flask. I might have should have made note of that. So these are two different methods. In both cases, you will want to read the procedure ahead of time so you know what you're doing. In the case of method 1, there's a little less prep involved in writing out the procedure. But you have to keep on top of it while you are doing the experiment. And sometimes you need to do steps kind of, back to back to back, just, in sort of quick, rapid succession. Maybe transfer, 1 milliliter of hydrochloric acid, or add 1 milliliter of hydrochloric acid, continuously over 10 seconds, then quickly transfer the reaction mixture to ice water, let's say. I don't know. So something like that, where you have to do things kind of quickly. So if you stop to write things down in the middle of it, well, that can affect your results. Method 2 is better in that regard, because you'll have written out the procedure, and you'll in the example I just mentioned, add your hydrochloric acid, let's say, check that off, maybe make a note 11 seconds instead of 10, whatever, and then you transfer to your ice water and check that off. So it takes a little more prep work to do method 2 here, but it does force you to read the procedure, and if you've written everything out, then it'll speed things up as you're going along actually in lab. So I would say I would recommend method 2 here, just because it's kind of, and I would do this when I was actually, like when I was a grad student, especially if I was doing the same procedure over and over again, like making a particular sample or running an experiment multiple times. I'd have my outline of what I was doing, and I'd check things off as I go, and if I found that something was different, like adjust the pH to 7.4 and I went to 7.42, that was still okay for my experiments, but I needed to note it in the lab report. All right, so we've done abstract, what you're going to do and how you're going to do it. Done procedure, what you actually did in lab, which you can do one of two methods. Next, we're going to have data. So let's take a look at data. So you want to make a table or tables for your data. You want to do that ahead of time is probably best. For the first lab, I actually give you some sample tables so you can recreate those, maybe make them a little bit bigger. But for other labs, I may not give you sample tables ahead of time. So, based on what data it looks like you're going to be collecting, you'll want to have a data table. So, for example, I could have, let's do an example here. So let's say I'll just make myself a nice little table here. That's why having the graphs is nice. The graph lines is nice. So we'll have mass of crude product, and then maybe we'll have the mass of pure aspirin. So we'll get these masses, and we'll have a melting point. I'll write it down here, softening point, crude, and then a melting point for my crude, and then maybe I'll have a softening point for my pure, and then I'll have a melting point for my pure. So I'll just go ahead and extend all these. And it's not the prettiest of tables here, but it's a table that is a table. So I really want you guys to do tables, okay? So maybe my mass of my crude product was 0.473 grams. My mass of my pure was 0.311 grams. My softening point of my crude was 129.1 degrees C. My melting point was 132.0 degrees C. Maybe my softening point for my pure was 133.2 degrees C. And my melting point of my pure was 134.7 degrees C. Okay? And I can also add in here some data for when I actually would do my calculations, let's say. Okay, so I could call this table 1, and then maybe I'd have another one, table 2, which has some additional things in it. So I might have percent recovery, pure from crude, and that's going to have a particular value. And then I've got appearance of aspirin crystals. And I'm putting these next to each other, but you could just, go ahead and have them, one below each other, however you want to organize it. So let's say I'll describe this as white powder. And now my percent recovery, well, that's actually something I'm going to calculate. Okay, so that is another thing. So your data is going to be tables of data. Okay, make a table ahead of time, write in the values as you measure things, include qualitative data as well. So let's add that up here. Don't forget qualitative data. All right. And yeah, so those are your data tables. And you can leave a blank for data that you'll be calculating later on. All right, so I had another Oh, I'll have to use this guy. All right, fair enough. All right, so let's take a look at on the other side now. So we got to look at that, right? Okay, so let's take a look then over here. We will have our, that's the wrong pen. There we go, calculations. Do on left or odd page can do in pencil. So let's say my example here So my example calculations here, I'll set this up, and so let's say I've got my percent recovery, and this is pure from crude, equals 0.311 grams pure divided by 0.473 grams crude times 100%. And if I go ahead and do that calculation here, 0.311 divided by 0.473 equals that, times 100 equals 65.8%. So now I go back over to the other side here and write in my 65.8%. Okay, so, you know, it's a bit of data that should be in a table, but I needed to calculate it first. And, you know, this goes for all kinds of calculations. If you're doing a percent yield, you'll need to do a stoichiometric calculation. For the, you know, the actual extraction lab, you'll want to do a, you'll need to do your calculation for the distribution coefficient, etc. All right. Okay, last thing to include here is, of course, the conclusions. So include your conclusions / results / discussion. Okay, and so for this, you'll want to restate your results, or state your results. So, for example, you would be stating your percent recovery, you state your melting point, things like that. You'll want to discuss those results. So we'll say here, discuss results with respect to, well, if you're doing a synthesis, you'd want to be looking at, say, the purity of your compound with respect to, so yeah, we'll say purity, yield, success, etc. You want to try to explain, so offer explanations for unexpected results. Or we'll say here weird, let's write that correctly, W-E-I-R, weird slash poor / etc. results. So if you got a 10% yield, you want to try to list some reasons for why you got a 10% yield. If your melting point was 5% off. You want to offer an explanation for why your melting point was 5% off. And I'll talk a little bit more about the types of conclusions to have in your lab reports when it comes time to do the actual lab reports. But for now, in your notebooks, you'll pretty much go along with whatever the procedure tells you to. There is some guidance, for example, provided in the lab handout for the solubility lab. So you want to be able to answer those questions at the end of your lab entry. Let's see, other things that you could include, sources of error. If there are things that you know might have gone wrong, you would want to talk about that. If there was something that possibly went wrong, but you don't know for sure, you could mention that. You may need to look things up, in which case you probably want to include some kind of some reference or something. But yeah, anyway. All right, so I think I've filled that out here. So now I can actually go back and look, and I can say that, okay, it looks like pages 2, 3, and 4 are my sample experiment entry. So I'll just go ahead here, go back to my beginning here. Sorry about that. And whoops, let's go back to the beginning here. So this is 9/2/24, and this is sample experiment entry. And I had that on pages 2, 3, and 4, so I'll just go ahead and do like that to indicate. And then I'd have, I'd start my next one probably on page 6. I'd have here, new experiment, wherever I happen to start it. And if you want to leave a few extra pages, or a page or two at the end of each lab, you can. You probably only would need to leave one, so you may want to skip one just to give yourself some extra room. It's helpful doing the calculations on the left. It gives you just more space to work with, and things aren't quite as cluttered. All right, so I did forget here, I want to include my sample experiment entry here. My date is 9/2/24. And then another thing that you want to do, I should have that on this side as well. And then the last thing that you'll want to do is go ahead and sign your, there we go, sign your notebook here. So, I've got my signature there and a date. And then Dr. P will come along, I will come along, and I will look at it and I'll say, okay, what about this part here? I may ask you questions, but in the end, I'll give you some score on my grading sheet, and I will sign off on it. And then I'll go ahead and do that on all the pages. And you should actually sign all of the pages. So I'm going to go ahead and add in the pretend signature here. And this is actually done, like, for example, in companies, you'll actually go ahead and, like, say you work at a biotech company. I did this when I was an intern. I worked in summers at a biotech company. I'd have stuff in my lab notebook, and after every few days, I'd meet with someone in the lab. Maybe it was my supervisor, maybe it was someone else, another, like one of the scientists, and, they would take a look at my stuff and say, okay, yeah, that looks legit. All right, let me sign it. And I would do the same, actually, with, sometimes we interns would look at each other's stuff. When I was in grad school, the grad students, we'd like exchange notebooks and go through and say, okay, yeah, this looks fine, and sign off on it, saying that, or basically agreeing that, yes, I saw this stuff that you did, and it makes some kind of sense to me. It says, like, often it'll say witness and understood by, whatever signature there. So anyway, phew, I feel like this has been a really long video, and but there's a lot that goes into having a good lab notebook. Okay, so again, one of the most important things is, or the most important thing is, to write down what you're doing. Okay, and again, it doesn't matter if it looks pretty, if it's a bit messy, as long as I can read it, I'm fine. And you have a few little, you have a little spot or stain somewhere. Well, gee, I knew you actually were in lab doing stuff. And it also reminds me of a saying that I got from Mythbusters, which is the only difference between screwing around, the only difference between screwing around and science is writing it down. Okay, so, the only, it's not the only thing, but the big difference between just, messing around with chemicals, which could be potentially dangerous, is the only difference between messing around and science is writing down what you did. Okay, so yeah, write stuff down, keep a good lab notebook, and in the meantime, stay safe out there. All right, bye now.